Hey everybody, I'm Chef Tom, and welcome to my workbench. A couple weeks ago, I pointed out that I had picked up this Commodore 128 off of eBay, but I had no way to tell if it worked. We're going to solve that today by building a power supply.
So everything we need is right here. In this box I have two project cases, because if I'm likely to screw anything up, it's going to be with this, so let's have a spare. A 9-volt AC power transformer. An excessively long grounded power cord. 5 fuse holders. 2 40mm fans that run off of 5 volts DC. I don't know if I'm going to need one or both of these, if I need any at all, but in case the power supply gets hot, I've got a cooling solution in mind. And a Meanwell 5-volt power converter. Additionally, in the envelope, I have 5 of the C128 5-pin DIN power connectors. I could have just bought one, but once you break down the shipping cost, 5 made way more sense, and if I screw something up, I want to have extras. We'll get our project case unpacked and opened up, making sure not to lose the screws this time. Then we'll do a quick dry fit to make sure our components lay out the way we'd like them to, making sure they fit both laterally and vertically, because we can't just trust the dimensions of the box. I'm holding 2 fuses to make sure they fit, because I'm going to use the same size drill bit to drill out the holes for both this and the electrical cable. Off camera, I've gone ahead and labeled all the wires on the transformer. I'm only going to need the 2 blue wires for the output side, and the black and white wires on the input side. I'm not running 240 volts, so I can ignore the red, and I don't need a 6-volt AC, so I can ignore the black on the output. Let's mark the holes to mount them, and then head out to the shop.
A few moments later.
I quickly checked and made sure that the 5/8 bit would be the right size for the fuse, and also the AC input. I measured in and made a mark 1 1/4 inches from the edge of the box, and then 3/4 of an inch and 1 1/2 inches up from the bottom. I also repeated these marks on the other side of the box, but we're only going to drill the lower hole at 5/8 of an inch, and the upper hole will be 1/4 inch so we can mount our end. I know most videos show people using a hand drill and a step-up bit, but I have the right tools to do this without that, so I'm going to take advantage of that. With the drill press, I can just line up the hole and go through, as long as I have the drill on the slow setting, which is where I keep it most of the time anyway. For the base mounting, I'm using a 9/64 bit from the inside to the outside and going all the way through. And follow that with making a counter bore on the outside with a 1/4 inch drill bit, just enough so we can bury the heads. Everything's looking good. Let's head back to the workbench. I grab 6 standoffs. 2 are 8mm standoffs, which are for the AC transformer, and 4 10mm standoffs for the AC to DC converter. In order to install these, I need to hold the standoff with a pair of pliers so it doesn't turn while I screw it in with the screwdriver. I'm also using a dab of JB Weld on each to make sure I get a good bond to the bottom of the plate. I guess it doubles as thread locker too. This process just gets repeated for all 6 of them. I mounted the fuse holder in the top hole so I can bring the electrical cable into the bottom hole. I've also added a grommet to the cable. And this will give me easy access to the tabs for soldering. In order to install our fuse, we'll trim our neutral wire, strip off a little bit, making sure to remove any orange caps that may get in our way and throw them on the floor. Add a short piece of heat shrink tubing, and solder it all together. We'll use our cutoff from the electrical cable to attach our other tab to our AC to DC converter. For the 5V AC to DC converter, I won't be using the Molex plugs, so I'm going to desolder them to give me better access points to solder directly to the board. Looking at this, I can see that since I only have the 2 soldering points, I'm going to have to solder the 2 wires together before I solder them to the board. Not a problem, just an extra step. And some heat shrink tube just to be safe. And pay no attention to the fact I don't own a hot air gun. The output of our 5V converter will give us 5 volts on the red line and ground on yellow and white. I know it's not standard, but these are the colors that I have in this wire. Since we're looking at this from the back, we can actually use the female connection, not the male connection, to line up our wires. And you can see I've scribbled out the colors that would normally be in there for the colors of the wires I'm using, with the 9V AC being blue and green. I didn't realize it at the time when I picked up the wire, but each strand is actually solid core, which means it's a little stiffer and a little harder to work with, but each strand is also small enough to fit into the peg, so I can just push it in and then solder it into place, which is really nice. A quick check for our 9V AC and 5V DC, and then we can see what happens. But before we close it all up, let's take one last look at all the pieces put together. Now the question is, does it work? Well, I can push the box over this way and show you. The LED is on, so at least the 5 volts works. As far as will it power a 128, we're about to find out together, because I'm not entirely sure. The first thing I'm going to do is make sure the 128 is turned off. Okay, off is down. And then attach our power connector, which goes on the side here. No shorts. Okay. I need to get out my handy dandy we'll get out our AV cable. Make sure we plug it into video. There we go. I'm going to run that into my retro tank, which I haven't used yet. We know retro tank will take that, and composite on green. I have to remember the power's on top of the bottom of that one. Okay. Turn on our TV. HDMI 1. Let's see what happens. Power light comes on my 128, but I get no signal. But that doesn't mean anything, because I don't know the retro tink. This is also the first time I'm using the retro tink, so I'm excited. No smoke, nothing hissing. The 128 turned on. So, new plan. We know this guy works. We built it. So let's do video 1. It's entirely possible here that the 128 doesn't work. And the only way I will find that out is to plug it in and get it connected. Oh, you know what? There's no power to the retro tank. We'll still use this anyway. I plugged it in, but I didn't turn on the USB power. All right. .720p, so it is seeing the upscaler. Does the Commodore 128 work? Sort of. I don't know what this is. Diagnosing and working on the 128 will be its own entirely separate video. The power supply works, and the 128 does turn on, and it does do something. So, I'm going to call this a win. We have a working C128 power supply. And, yeah. I will figure out the rest of this later.
Thanks for watching. If you enjoyed this, go ahead and press that subscribe button in the center of the screen. I've also got a couple other videos I think you might enjoy.